It's very important you have a solid grasp of formal charge because we're going to be dealing with many charged molecules in this course. So what is formal charge? Formal charge is the charge assigned to an individual atom. So we're no longer going to be putting brackets around a molecule with a molecular charge. Now we're going to be assigning charges to the atom that it belongs to. And it's typical on atoms that have an unusual number of bonds. So we spent some time looking at the ideal number of bonds for various atoms. When atoms don't have that ideal number of bonds, it's likely that the atom has a formal charge. The calculation we're going to use for formal charge is this. We'll take the group number, or the valence number, from the periodic table, subtract the number of bonds, subtract the number of lone pair electrons. So let's look at a couple of examples. In this first one, what I want you to automatically be able to spot is that the nitrogen has 4 bonds. A neutral nitrogen has 3 bonds. That's nitrogen's ideal bond number. So as soon as you see an unusual number of bonds, that should kind of spark your attention that there might be a formal charge on the atom. Now we need to make sure there's no hidden lone pairs or anything like that. And in this case, the nitrogen does not have a lone pair because it has its octet already. 2, 4, 6, 8 electrons are accounted for, so that's all we have on the nitrogen. So now to calculate the formal charge, we take the group number from the periodic table. Nitrogen is in group 5. We subtract the number of bonds. This nitrogen has 4 bonds to it. And then we subtract the number of lone pair electrons, and in this case there's 0 on nitrogen. So 5 minus 4 minus 0 is positive 1. That nitrogen has a positive 1 formal charge. We'll represent that by putting a plus on the nitrogen. I like to put circles around my charges. In our next example, we have an oxygen that has an unusual number of bonds. So oxygen likes to have 2 bonds. In this case, it only has 1 bond. So we can hypothesize that it probably has a formal charge. But what's missing from this oxygen are the lone pair electrons. And we can assume that there's enough lone pairs on it so that it has an octet. So right now the bond to the oxygen is 2 electrons. 1 lone pair gives us 4. Another lone pair is 6. The final lone pair, now we have 8 electrons around the oxygen. So now to calculate the formal charge, we take oxygen's group number, which is 6, subtract the number of bonds. Oxygen just has 1 bond here. And then we subtract the number of lone pair electrons, not the number of lone pairs. There's 3 lone pairs, but there are 6 lone pair electrons. 6 minus 1 minus 6 gives us a negative 1 formal charge. So this oxygen bears a negative charge on it. Here's one more example. Now we see we have this sulfur that it does have an unusual number of bonds. It has 6 bonds. Now, it also has more than an octet of electrons. But because sulfur is in period 3, it's down below oxygen, it has those extra d orbitals, and those atoms can have expanded octets, so they can have more than an octet of electrons. But if you're dealing with the row that carbon's in, we have boron, carbon, nitrogen, oxygen, and fluorine. Those can have an octet of electrons max. But then once we go down to period 3, like where we have sulfur below oxygen, then we can have an expanded octet. So here we can still use our same formal charge calculation. The formal charge, sulfur, like oxygen, is in group 6. We subtract the 6 bonds that are around the sulfur. and the sulfur has no lone pair electrons. So 6 minus 6 minus 0 is 0. So sulfur does not have a formal charge in this case.